Hello everybody. Tonight we are going to be working on our homework for Chapter 39. The chapter topic, of course, is Java Server Faces. And we've looked at a lot of different example problems by reading the chapter and kind of trying some of those out. And remember that Java Server Faces is the modern web approach for Java, the one that Oracle really wants you to use. And really is a superior approach in many ways to the two previous technologies, which were servlets and JSP. So we're going to look at the first exercise. So I'm going to pull up the PDF of the chapter, and we're going to be working on 39.1. And this one's called Factorial Table in JSF. Now, can I ask you guys, are any of you guys ever been math people, like math majors? Probably not, right? Because you'd probably be working for some big corporation now if you were. So you probably don't even know what a factorial is, right? And so what do you do if you're asked to develop a factorial table? Yep, Google, hello. Right, but they do have an example of what it should look like. And this is what a factorial, or the output you're looking to generate. You're not really looking to generate anything fancy, but you can see clearly that you're building a table and that there's a number in one column and the resulting factorial in the adjacent column. All right, so let's actually do that task of typing in what is a factorial. All right, and Google doth say the product of an integer and all integers below it. Okay, that's a really simple statement, isn't it? Right? So for example, 4 factorial is equal to 24. So if you think about that for just a second, you know what, and I'm just going to bring up like Notepad or something. I'm not even going to do Notepad++, I'm just going to do Notepad. That means that you're doing 4 times 3 times 2 times 1, right? 4 times 3 is 12 times 2, 24 times 1 is 24. Okay, so that's what we're doing. However, there's a couple of stipulations to it. The stipulation is that what happens if it's 1 factorial? Well, that's 1, right? What happens if it's 0? Yeah, the table said 1. Right, and that's the thing that always gets you, because how does that work? Right, and I think that what helps a little bit when you do these weird like number things is actually to look up what it all means when you see examples of it. Now, what's really fascinating about this as a mathematical formula is it is actually recursive. What does it mean to recurse? You guys maybe haven't even learned this concept yet. So what that means is that part of the solution to solving it is to call itself to solve the problem, right? So if I'm multiplying against a number, against a number, against a number, well, it sounds like we could do it in a loop. And in fact, we have to do it in a loop. But there's also the stipulation that we can't really apply the formula to 0 for whatever reason. So you have to actually come up with a conditional statement for 0 so that if the number is 0, the answer is 1. Otherwise, run the formula. And then when you run the formula will call itself to run the formula again. So how you do that, wow, okay, so that's a little bit of a mind bender, because now I got to take this equation that I'm seeing and actually try to convert that to code, which is a whole different step. So if I put in the number 5, that means I'm also going to have to call 4, 3, 2, and 1. So how do you do that? Well, there's actually a formula that, right? So if you study calculus, right, and this is one of those things when you learn calculus, you start to see formulas like this, and you go, oh my God, I want to run for the hills, right? But really, it's pretty simplistic. Really, the basic formula is this one here. Okay, So the formula means that n factorial, so whatever number you pump in, well, the exclamation represents factorial. It's just what somebody said. We're making it that. Okay, sounds good. All right. N stands for any number, but the basic formula is the number times the number minus 1, right? So I'm going to do 5 times 4 times, so that just keeps going, right? So there's where the loop is, the recursion. And what they do here in a calculus format, they actually have a whole syntax for how that works, because when you put in one number, you have to put in a whole range of numbers, and that's how they kind of broke this down. I think it's pretty fascinating because, okay, n times n minus 1, but notice that after that n minus 1, there's another factorial, which means you're back here again, which means you have to call the equation again to get the next number. That's the recursion, right? And actually, that's a really bizarre technique because in programming, usually when you think about if you have a loop that calls itself, what problem do you run into? Infinite loop is a definite possibility, so you need to have some way to terminate it, and that's one problem that people will run into. Okay, so this is the basic formula we're trying to replicate. Now let's turn it into code. Okay. Boy, that's a mouthful, right? All right, so in order to build this, oh yeah, I got the answer on the screen already. I got to change it. Ooh, you guys can't look. All right. So I'm going to close all my previous work here, just kind of get it out of the way. And I'm sure there's a close all somewhere here. Close all project. Sounds good. All right, so I'm actually going to put in, or open up a new project. Not new file, but new project. It is going to be Java web application, so you guys are used to this process, right? Maybe not. Let's call it exercise 39 underscore 1. If you want to call it factorial, you could do that too. That's fine. Choose where you're putting it. We're going to use Glassfish for our server. No reason to change anything on this page. And we are using Java server faces, clearly. All right, that was being a little weird when I clicked on it. It didn't immediately respond, which I thought was strange. We don't need to make any other selections, so once you've done that, go ahead and click Finish. And then this will build out the project framework for us. Now, what's fascinating here is we don't really need a lot of stuff on the HTML page that it generates. Because the math that we're going to do, remember the way Java Server Faces works, is it allows us to just use regular Java files on the back end. That's really the beauty of it. Where servlets and JSP don't quite do that. JSP actually is more like PHP, where you put the Java code right in your HTML. And that's a little weird, right? But let's see if we can set up our interface first. So I'm going to go look at the document here. And clearly we're going to have to put in display factorials, right? Looks like an H1 or something like that, right? You guys remember your HTML, I hope. So maybe instead of hello from facelets, we can just, drop in an H1. And we can say display factorials. Like so. Good? All right. The other thing that we're going to need to do is we're also going to need to have a place to take the output from the Java file and push it back into the HTML file. So we need some sort of a container for that. Now, this framework that we're using has a bunch of different tools for doing that. The one that I'm going to use is a really simple one, and I don't expect you guys to memorize this stuff. Reality, right? Programmer's truth. If you guys get a job where you're doing this stuff all the time, you will learn this backwards and forwards. You can go back, revisit it, and study every different output method if that's all you do in your job. I'm not going to make you memorize this stuff. There's no point because I don't, frankly, I don't. Why should you? Right? Okay, so just please think of it like that. All right, I am going to use a tool called Output. Oops, got my colon. Okay, so now I got to type it over again to get that IntelliSense. So I'm going to use Output Text. And why Output Text? Because what we're going to be sending back is basically that in the form of HTML and the numbers that go in the table. And then we're going to add a couple of things here. So one we're going to do is we're going to do an escape equals false. And I'm sorry, I'm fumbling here. I'm more of a Eclipse person than a NetBeans person. And you know what? We could put in some style elements if you want. Or you could write a separate CSS file. I'm not going to style it in any particular way, but I'm looking at my example from last year. Last year, for whatever reason, I chose to color it red. Okay, so take it for what it's worth. And then the other thing is we will put in a value tag. Turn off our caps lock first. And the value tag is where the output's going to end up. Now, right now, I don't really have anything generated, but the thing I do remember is that inside those double quotes, I'm going to put in a hash mark, a set of curly braces, and then whatever my bean that I'm using, that's going to be called the Java program, and then I'm going to pull a response back from it. So I'm going to, I don't have that code written yet, so I'm going to have to come back here and add it. So right now, here, I'm just putting question marks and let it underline. Okay, because if it underlines, I remember to go back to it. Okay, that's my thinking. And you know what? We're done with the HTML. Except we got to close the H tag here. So I'm going to just do a self-closing tag. Okay? Do a Control-S and save that file. And you know what? I left this one in index. Did you guys notice that? I didn't give it a different name. I just left it in the index file. In previous iterations, and what the author does in his examples, is he usually names it, he creates a separate HTML file for it. I really don't see the point, because this is kind of like all we're doing in here, so why create something else? All right, so now we have to do the manage bean part. Do you guys remember that? It's okay to say no, right? Because we were just looking at examples, so unless, the way you look at it is unless you're really, doing the work, you don't really get into the habit of it. So that's our next step here. So what we're going to do is we're going to open up the source packages here, and I'm just going to right-click here, and I'm going to go ahead and add a managed bean. All right, so now we have to make some choices here, and these are actually kind of critical choices too. All right, so let's give it a name. How about, what should I call it? Give me something creative. Okay, since you guys are so damn creative, I could call it exercise 39.1, or I could call it compute factorial, spelled correctly, of course. I like that. That tells you what it does. Where are we placing it? We're going to put it in the source packages, and we're going to use the default package. That's fine. So I'm basically leaving that blank. If you wanted a named package, go for it. There's no harm done. And keep in mind that package structures within applications are really more useful when the application gets complicated and you want to logically separate your code into pieces. Largely because at some point in time, you might actually reuse it for something else. Okay, so otherwise this is fairly irrelevant. So we got the name here, and then it's got the scope thing. Now, there's a bunch of different things, and if you read the chapter at all, and I always make the assumption you guys did, right? I'm sure you studied it backwards and forwards. There's all these different options you can choose here. Now, the one that we're going to use is just request, very simply because we're going to request the information from the application, and it's going to send it back. If we were doing something where we were maintaining a session state, we'd use session. If we're doing something where we're just generating something we're going to look at, we would do view. And all of them have scenarios. And frankly, many of these might work to make this work. But this one is probably the best choice for this particular scenario. So that's what I'm choosing. Right. And I am getting the warning, it's highly recommended you not place Java classes in the default package. Too bad. Because that's where I'm putting mine. All right. You see that the tool automatically generates a bunch of stuff for us, including naming it, compute factorial, and puts in the request scope, and creates the class and a blank constructor function. All right. Now what we're going to do inside here is we are going to actually replace the constructor function. We're not going to instantiate a class here. All right. What we are going to do is we're going to do some math and some output. Right. Now remember, when we do output in Java server faces applications, we write a method called getResponse. Remember that? And then you can either call it getResponse with the parentheses or just response. Either one works. So that's what I'm going to do. So I'm going to create a public that's going to return a string, right? Because we're going to keep in mind what we're going to send back here is HTML, which is just text. Okay, and we're going to call it getResponse. Parens. We are not passing it any values. We add our curly brackets, like so. Don't worry about any underlines right now. Now, what I'm going to do here is, knowing that I'm sending back a string, I'm going to declare a string variable, and at the end of the method, I'm going to return that string back to the HTML page, and it'll have all the HTML table built right into it. Cool, right? I think. All right, but I'm easily amused. So, all right, declaring a variable, and I'm just going to call it S, or I can call it HTML, or whatever. I'm just calling it S. Why? Just that was where my finger was. And what I'm going to start doing here is a technique that you guys may have seen in other languages when you're building web content from a back-end language. Sometimes you write a little bit of HTML, store it in a string, and then you run something in the program, generate some more HTML, and append it to that string. So I'm going to do I'm going to start the table, and then as I generate each row of the table with the numbers, I'm going to plus equal it into the string. And at the end, I just return the string. It's kind of a clever little technique. I really like it a lot. All right, so here's the table. And you know what? I can actually put a border in. Right, but if I do a border and I need to use double quotes, now I'm running into problems because I'm using double quotes. So what do? I actually have to use an escape sequence to put in a border. Now, the only reason I'm putting in the border is not because I think it aesthetically looks great, but because the book is doing it. All right. Could you do this with CSS? Yep. And since I'm beginning the table, this is going to be my first tag. When I use this type of technique, what helps me a lot is I put in concatenation marks and then build the string like I would a regular HTML file. I just throw concatenation marks in there to help me assemble it. So here we go. I'm going on to the next line, and down here I'm going to add in the table row because we know we're going to need that to start out with. Right? And if I was writing HTML, I would put that on a line by itself, so I'm putting it on a line by itself. If you look at the PDF file, the first thing I'm going to build is this, number and factorial. I'm going to build that table row. So I got to finish that task. So to do that, I am going to create double quotes. I'm going to create a table data cell, a TD. And then inside the TD, I'm going to say number. And I'm going to close the table data cell. And then, as I would in HTML, I'm going to add another line. It's going to be another TD. And this one's going to say factorial. And then I'm going to close that TD. And then you know what? I'm done with that row, right? So I'm going to close the row. Like so. And that's enough for now, right? So I successfully begun the table and put in the first row in HTML format. Now, we need to recognize that there's a pattern here that we have to finish off, right? So with the remaining portions of this is hard-coded, obviously, right? But the rest of this is going to require a mathematical formula to generate the number. The first number, if you guys notice, 0 through 10, that's sequential. We can do that with a loop. So we can kind of like let the loop run and then use the loop control variable, you know, whatever our index value is, and just print it out on the screen each time for that spot. The other one, when we get to the other table data cell, then we have to run the math to put the number in. So every time we loop, that second cell has to have a call to wherever the math is. So, we have to write a thing that's going to do the math. Okay, so I'm going to kind of be slightly preemptive and anticipating that I'm going to write a math function. I'm actually going to create a private method. It could be public too, I suppose. But private, of course, means that it's only accessible to this code. You don't want the outside world getting to it. The output that we're going to generate, you got to be really careful here. The table that we're working with, that goes up to 3,628,000 whatever, right? That's getting pretty big already. So an integer might do it. A double would be safer, but a long would be better. Because what if we do it like 0 to 100? See, little stipulation there. So what I'm going to return is a long. I am going to call it compute factorial. Now you guys will say, hey, I thought you said you weren't going to do that. Well, I guess I am. And actually, you know what? Let's just call it compute. Because now I'm recognizing I named it the same thing. Okay, so sorry. Let's call it compute. Or do the math, something like that. I'm just going to create my curlies. And for right now, I'm leaving that alone. But that way, even though I don't have any code in there yet, when I add the code up above to call it, it won't flag red. That's kind of my thinking. Okay, so back up to the getResponse method. I'm going to create a new line, and here's where I'm going to start my loop. So I'm going to do a for, put in my parens. I do need a loop control variable, so I'm going to set I for my index, and I'm going to make that equal to 0. When are we going to run that? We're going to run that from I less than or equal to 10, right? So we'll start with 0, and you count up to 10. And then, of course, that means that we're doing an I plus plus. Right? Once again, let's get some curlies in there. So let's conceptualize here. Every time this loop runs, it will first output a new table row, right? And then in the first cell, it'll just take I and put it on the screen. Simple. Okay, so watch what I do. Since whatever I'm doing, I want it to add to the string that I've already created, I'm going to say S plus equals, and then, I'm going to put in quotes, TR. Oh, I've got to put the brackets around it, of course. That's enough for one line. All right. And then, of course, if I'm doing that, then I guess I'm doing TD also, right? So I may as well just copy that, paste, and change the R to a D. And you know what? I'm also recognizing that since if I was writing HTML, I would then insert my I right there. Then I'm just going to concatenate right after this the I. And then I'm going to put in the closing TD. All right. I'm sensing questions. Yeah, you can. Right. You know, so Bella, here's my thinking. Absolutely. I don't have to concatenate them like this. I could write it as one long string. That's fine. But see, the way I'm doing it and what works well for me is that by doing it like this, I would lay it out just like I do HTML, and I don't lose my place. Okay? How you choose to do it, I don't care. As long as it works, right? But for my mind, it's just easier to see. And then if it's easier to see, my thinking is I don't make as many mistakes, right? I don't have to go back and fix stuff. All right? So there's the TD, so that's the first cell, right? Now we need to do the factorial. So we're basically going to kind of repeat this line because we're doing TDs again. But in the middle here, we're not going to print out I. We're going to call the method below to do the math, which is compute. What are we computing? I. We're sending I down there. And then, of course, if we are opening a table row, the next thing we need to do is close that table row. So I'm putting it back in here like that. Now it is flagging red, and I'm not freaking out to that because I'm anticipating that. Because if I'm dropping that in, it needs to be doing something, and I don't have it programmed to do anything yet. Okay, so we're off to a good start. Actually, you guys realize we're almost done? That's kind of the beauty of this, right? Because that little for loop is going to fill the table for us. And then when we're done filling the table, what do we have to do? Close the table. So right after the for loop here, what we really need to do is we need to do a s plus equals some quotes and close the table tag like so. And of course, a semicolon at the end. All right, from there, when we're done closing the table, now we're ready to send the string back to the web page. So all we have to do is type return s. Done. Beauty, right? So it's really cool if you start to conceptualize what we did, where you're writing code, we're calling a method, which helps us to fill in our code. It all builds as one long string. We save it in a variable, and when we're all done writing it, we send it back, and it just pops up on the web page. Right. That's correct. Right. Yeah, that's a big light bulb, isn't it? Like when I first realized that too, I'm like, this explains why that code looks so messy when I do view source, right? Because this, when it outputs to the browser, what's going to happen is it will be one super long string that's like as long as you make it. So if I ran it 100 times, it would like go off to infinity to the right, right? So, okay, so some people get really kind of weird about that. So what they do is they start to code line breaks. Like if you really want to get like, because then they're worried about making their HTML look nice. And people do that. They put in escape characters to make it output a line break so your HTML looks neat. In this case, I wouldn't bother. And honestly, who cares if it works right? Right? Because all you're doing is helping somebody else copy your code. So don't bother. All right, let's go to the math part and try to convert that formula that we saw here. So n factorial is equivalent to n times, in parentheses, n minus 1 factorial. which of course calls itself again, the recursion. All right, but we have that scenario that if you put in a 0, it returns 1. So hey, that part of it sounds really easy to write, so let's write that part first. In fact, why don't we just say if, we gotta actually pass a value in, don't we? That's why it's underlining red. So what are we sending in? An integer. And let's just call it n for number because it works with the formula, right? They always use n in math. So here we're going to say if n equal, oops, not plus, equal is equivalent to 0, return 1. Why? Because that's what the formula does. Else, and I know I'm only putting one line of code in there, so I really technically I don't need the curly brackets here, but I'm in such a habit of doing that. Then we do the math. Now the beauty of the math is, so here's the math, remember the math, n times n minus 1 factorial. Okay, but this is the fascinating part. How we do that is we just type compute. Yeah, this is the mind blower, because this is how we do the factorial. It calls itself again. And therein lies the danger of the recursion. And mine is underlining, I'm not really quite sure why. So let's hover. Oh, I know why. Because I'm just doing math in space without putting it anywhere. I could either put it in a variable and return the variable, or you know what? I don't need to do that. All I need to do is return it. Okay. All right, I'm going to record that into the video. So one of my onliners posted this. You could also write if n is equivalent to 0 or n is equivalent to 1, return 1. Yeah, you could do that. Absolutely, Aaron, you're right. So you could do that also. Really good problem solving, right? But this will work as well, because if I do pump 1 in, it'll go past the first part, go to the else, and then call itself. But isn't that really clever? And it's a lesson in really an important computing concept too, because recursion is a programming technique that can be used in a lot of different types of situations, because sometimes when you're doing something, you need to do it again. Think of tasks that you do that call for repetition. So you don't have to write the code over, you just call yourself, or call itself. Okay. So folks, that is all of the code for the bean right there. So take a moment and check it out. And then also be really careful with your syntax, because this is only going to highlight Java errors, right? It's not going to highlight your HTML errors. Right? So the HTML errors are on you. Yeah, it doesn't care what you put in, right? When it goes back to the web page, it will care. And then you know where you see the mistakes is in your browser, right? Fortunately, HTML is a pretty forgiving format. All right, so we got a lot of work done here. Now we're going to go back to our HTML page, and in place of the question marks, we are now going to put in the following command. We're going to put in compute factorial, and we can either do get response parens or just response with a lowercase r, like so. So the question I got here from one of the students was, what does escape stand for? And frankly, I didn't know how to answer it, so I went to the book and did a Control F and found it. And here's the answer to that. So it says, if you set it to false, basically to enable it to be displayed in HTML. Otherwise, it displays it as regular text, which then converts it into code as opposed to HTML. So that's the why. Yeah, that's basically the answer. Exactly. It will work either way. That's just considered kind of like a safety feature, I suppose. All right, at this point, you know what? We're ready to run this thing. Let's do a save all to be on the safe side. So we got our save all. I don't see any underlines except for misspelled words, but that's okay. And let's go ahead and hit the run button and cross our fingers and pray that it works. All right, our Glassfish server is firing up. Seems like it's taking its sweet time. Don't worry about any warning messages that Glassfish throws at you, unless it's like, hey, I'm not working. I have had students that saw those like little red blurbs of text and try to fix it. I'm like, no, don't do it. It's fine. Really, don't mess with it. All right, so it's coming up on my second screen here, of course. So I'll pull the tab over, and voila. And hopefully all the numbers are correct. How do you verify that? Well, look at the table that's in the book. I think the fact that it worked the first time is pretty good. No mistakes. Let's take a look at the view source, though, right? This is the fun part. And there it is. Really, really messy table all on one line. Do we care? Hell no. Why care? They don't like it? Too bad. In fact, what some programmers do is you could like probably code into your NetBeans if you want a little, even into the bean, you could write a little message that says, you know, S plus equals, and I'll put in an HTML comment. Right? And have a little fun with it. Nobody's ever going to see it anyhow. Who looks at the source code of a web page? Geeks. Right. Oops. Yeah, so you can save that and run that if you want. Of course, the subsequent launches usually are quicker, of course, on my second screen again. And then we can view source and look at our comment. All right, so let's call it on that one, and we'll take a break here in class. It's a good time to stop for a break. All right, we'll see you in the next video.